Hello and welcome to this second lesson on solving linear systems algebraically. Hopefully you watched the first lesson on solving using the elimination method. This lesson will be focused on something called the substitution method, which is just another way of solving systems of equations algebraically, so like manipulating the equations and solving for variables and stuff. And then we're also going to get into some harder types of systems of equations and how you would solve them. There is no new vocabulary here, so let's just get into it. So, the substitution method is, as the name suggests, we are going to substitute some stuff, and our goal is kind of the same as the last method. The last method, our goal was to make one of the variables eliminate, because we can only really solve an equation if there's one variable in it. Like here, I've got an x and a y. I can't find either of them while I have an x and a y. If I could make this have like, if this was an x and this was an x, then we could solve the equation. I could combine my x's together and then solve and get the x by itself. Well, that's really what the substitution method is all about. So check this out. This equation is solved for y, meaning it's y equals. That is the requirement for the substitution method. You have to have one of the variables, x or y, to be by itself. So what I'm going to do is I'm going to say, hey, if this stuff, if this stuff here is equal to y, then if I plug it in right there, I'm going to have this new equation, x plus 2 times 3x plus 2 equals 11. So I plugged this stuff. Why is this junk? I plugged it in for y. And look at this. I now have an equation with only one variable, x. Now, I've got two of them, but I can combine those x's together and then solve that equation. And that's really what the substitution method is all about. So to solve, now it's just normal solving junk, like I'm going to distribute 6x plus 4 equals 11. I'm going to combine 7x plus 4 equals 11, subtract 4 on both sides, 7x equals 7, and then divide by 7 on both sides, and x equals 1. So I've found the x coordinate of my solution. And just like with the previous method, once you've found the value of one variable, the way you find the other one is you take that and you plug it in. So x equals 1, I could plug in 1 here and solve this, or I can plug the 1 here and then solve that. I'm going to do the first equation here. So y equals 3 times 1 plus 2. I plugged in my x value of 1 for x, and now when I solve that equation, y equals 3 plus 2, y equals 5. That is my solution using the substitution method. Now, many of the equations are not going to be set up for the substitution method. Here, my y is not by itself, my x is not by itself in any of my equations. So in order for us to do the substitution method, we would have to take one of these equations and solve for y or solve for x. Now, there are times that if you are good at mental math, you can look through and figure out which ones are going to give you the least number of fractions. Like if I solve for this y, I'm going to get a fraction from my x. If I solve for x, I'm going to get a fraction for y. The only one here I wouldn't get a fraction for is if I solve for this x right here. But that's just I know that because I can do the mental math very quickly in my head, and I've experienced doing this, but you probably wouldn't know that. So let's see what happens if you get a fraction. Okay, I'm going to solve for this y right here. Okay, I'm just picking something. Okay, so I'm going to solve for y. So if I subtract 3x on both sides, negative 2y equals negative 3x plus 12. I'm going to divide by negative 2 on both sides, and y equals a positive 3 over 2x minus 6. So I've solved for y. That is one of the first steps of using the substitution method. You have to solve for one of the variables. I could have solved for this x, or I could have solved for this x, or I could have solved for this y. I chose this one. Now, once you have that, we're going to take this junk. It says y equals this stuff. I'm going to take that stuff and plug it in for y. So I'm going to have 3x minus 6 times 3 over 2x minus 6 equals 36. And now I have an equation with only one variable. It has just x's. So I'm going to solve. I'm just going to like distribute my 6 and combine my x's and get the x by itself. So if I distribute the 6's, I'm going to have 3x minus, I believe that's going to be 9x. Let's see, 6 times by second alpha. And the reason why I'm using this calculator, folks, is because this lesson is designed for the folks in the algebra class already, or the folks who are planning on taking algebra next year, the honors algebra next year. So to do that fraction, it's second, or alpha y equals. Okay, so it was, I multiplied, I got 9x minus 36 plus 36 equals 36. I'm going to combine these guys together. That gives me negative 6x plus 36 equals 36. I'm going to subtract 36 on both sides. Negative 6x equals 0. Don't let that concern you. It's still a number. Don't stop here and go, oh, no, I don't know what to do. Keep going. Get the x by itself. Divide by negative 6 on both sides, and x equals 0. So the x coordinate of my solution is the number 0. So it took all of this work to get down to here. If I would have used the elimination method that we learned in the previous lesson, it would have taken 3 steps to get this far. I would have lined up my equations. Everything's already lined up, x's and y's. I would have multiplied one of the equations by negative 1 to make a positive 3x and a negative 3x to make my x's eliminate. And then I would have eliminated, and I'd been done. So that's what I'm saying, like this substitution method a lot of times is more work. Here, it was probably about the same amount of work, maybe a little bit less work than the elimination method. But a lot of times it does give you more work. Now, once you got one variable, the work after that is the same. Now what we're going to do is we're going to plug in 0 in one of our equations that has x's and y's, and we're going to find the y value. So I'm actually going to plug it in right here. I have space under this equation. This equation has both x and y in it, so I can use it. So I'm going to plug in 0 for x. Y equals 3 over 2 times by 0 minus 6. Y equals negative 6. And that is my solution. So there are definitely problems that are easier solved with substitution, and there are definitely problems that are easier solved with elimination. I will not specifically tell you you must solve using substitution or you must solve using elimination. You're going to have that choice. I'm showing you multiple methods, and you're going to make the decision on, would this be better using elimination? This problem would have absolutely been better using the elimination method from the previous lesson, where some problems are much easier using substitution. This problem is set up for elimination. See how one of the variables is already y equals? That means this problem will probably be just as easy or easier to substitute and solve and get one of the variables. Where if you had to do the elimination method, you'd have to like subtract x on both sides, or on this side here, get your variables lined up, and then move them over here and multiply one of the equations by something to make them have common coefficient, and then you can eliminate. It would be longer using the elimination method. Okay, that's why you're learning both, so you can make the informed decision on which way is easier. So, I would like you to pause the video, and I would like you to do this problem right now. When you are ready to continue, hit play, and we'll go through it together. All right, so this was definitely a substitution problem because it's already y equals. So I'm going to take this, 2x plus 3 times by x minus 7 equals negative 1, and I solve. So 2x plus 3x minus 21 equals -1. I distributed my 3 through. I'm combining like terms. 5x minus 21 equals -1. Add 21 to both sides. 5x equals 20. And finally, when I divide, x equals 4. So I found the x coordinate of my solution. To find the y coordinate, I'm going to take x equals 4 and I'm going to plug it in up there. So y equals 4 minus 7. Y equals a -3. So there's my solution, 4 comma -3. X is 4, y is -3. And that wasn't too bad. Now, also, you folks have a graphing calculator. We saw how you can solve by graphing. Well, you can actually solve these problems by graphing as well. So if I took this equation and I plugged it in, so I'm going to type in x minus 7. That's this equation, y equals x minus 7. My second equation, I would have to solve this for y. I can do that. I don't have a lot of space here. If you want to keep any of this work, pause the video. I'm going to delete it, at least this chunk of it. I'm not going to delete this solution. If I solve this equation, the second equation here for y, if I subtract 2x on both sides, 3y equals -2x minus 1, divide by 3, divide by 3, y equals -2/3 x minus 1/3. That would not be very fun to graph by hand, but with a calculator, sec alpha y equals, I'm going to use this fraction of -2/3x minus alpha y equals 1. And I don't want to put a negative here because I already have the minus. If I put a negative, it'd be minus a negative would turn this to a positive, and that's not what we want. So 1/3. So here we have this. So those are my two equations. I hit graph. There's the one line. Being a little slow. There we go. Here's the other line. It's thinking. It's thinking. They're going to intersect around here someplace. Now, in order for us to figure out what that number actually is, we are going to use this calculate feature. So it's blue above trace. So we're going to hit second trace to calculate. And we want to calculate the intersection point, number 5. First curve, which line are we talking about? Well, right now my cursor's on this line. Sure, that line. Second curve, so where my second line, it's on this one right now. Yes. And then guess. Where is this intersection happening? I'm just going to go over a little bit. You just want your cursor to be close to the intersection point. And I hit there, and it calculates, and it gives me the intersection is the point 4, and y equals -3. And look at that, 4 and -3. So you can do this with your calculator. That is kind of like the advantage of having a graphing calculator, is paying the extra, I don't know, whatever, $80 or so to have this type of calculator versus the other one, is you're allowed to use this graphing calculator on all your tests, all your quizzes, on the PSSAs, on everything. So if you know this feature, it makes solving systems of equations easier. There is still legwork. You still have to have both equations as y equals in order to do this. There are times where when you solve, you will not get a nice, pretty answer here. So solving by using the calculator is not always like the best method. I might get a fraction of, say, 1/3 or 3/5 or 3/9 or 3/17 that would come out pretty as a fraction here, but in here would look like just a big, ugly, jumbled mess of numbers, okay? So this is, again, another method to add into your toolbox. You now have elimination, you have substitution, you have graphing by hand, you have graphing using calculator that you can use to find the solutions to systems of equations. All right, letter D. Find the value of both variables. All right, so here, this equation is a little bit different because now it's x equals. that doesn't change the math at all. All it's saying is now I'm going to plug this junk in for the x instead of plugging in for y. This problem is set up for for substitution, because I can immediately right now substitute this junk in for the other x. So let's do that. So I'm giving myself some space. Negative 4y plus 39 minus y equals negative 43. And now we solve. I have an equation with only one variable. It's just y's. And so we solve. Positive 20y minus, I'm not sure what negative 5 times by 39 is. 195 minus y equals negative 43. Notice I did not take the negative 5 times by this y because he's not inside the parentheses. Combining like terms, that's those two, gives me 19y minus 195 equals negative 43. I add 195 to both sides. You should be very familiar with this by now, so you can kind of speed through this just like I'm speeding through this. Negative 43 plus 195 is 152, and then we divide by 19 and divide by 19, and y equals divide by 19 is 8. So the y value of my solution is 8. Now in order to find the x value, I'm going to take that 8 and I'm going to plug it in for y in that equation. So x equals negative 4 times by 8 plus 39. X equals negative 32 plus 39. X equals 7. 7. And that is my final solution. 7, 8. In order to graph this using the calculator, I would have to take each of these equations and solve for y. So make this one y equals. You can't plug in an x equals in here. This is y equals. So you have to solve this one for y. You'd have to solve this one for y. Then input both of them in the calculator. Then graph them. Then use the trace feature. It's a lot of steps. It was probably easier to actually just do it by hand this way. Okay, letter E. Another practice problem for you. Go ahead and pause the video and do it now. When you're ready to continue, hit play and we'll go through it together. All right, so this one is y equals. So we're going to plug, over there. They kind of fooled me a little bit. They put the y on the kind of the wrong side. They put it on the left-hand side. Usually x's comes before y's. So I had to really catch myself there. So now this will become 5 times negative x plus 7 plus 4x equals 32. Negative 5x plus 35, I'm distributing, equals, or plus 4x equals 32. I combine like terms, gives me negative 1x plus 35 equals 32. I subtract 35 on both sides. If I'm going too fast for you, you can always pause the video and watch it again or slow it down. If I'm going too slow for you, you can speed it up using the YouTube settings. Divide by negative 1, divide by negative 1, x equals positive 3. Boom. And then once you got that, you can plug in x equals 3, so y equals negative 3 plus 7. So the negative is from here, the 3 is from here. That becomes a negative 3. And negative 3 plus 7 is a positive 4. And that is my final solution. I'm going to allow you to solve this problem any way you like. If you'd like to solve using substitution, you may do that. If you'd like to solve using elimination, you may do that. Pick a method that works for you. I'll be honest, elimination might be the easier method here. I'm sorry, substitution might be easier. It's about even, honestly. So I'm going to solve using substitution. So if you want to follow along with me, do the substitution method. Go ahead and pause the video. Try it on your own. When you're ready to continue, hit play, and we'll go through it together. All right, so substitution method says this is already x equals. I'm going to plug it in right there for x. So now my equation is going to look like negative 2y minus 6 equals negative y plus 2. I substituted this right here. So now it looks like an equation with variables on both sides. I just do normal solving equation junk. So I'm going to add y to both sides. Negative y minus 6 equals 2. I'm going to just solve my equation. So I'm adding 6 to both sides. Negative y equals 8. Divide by negative 1 on both sides, and y is a negative 8. And just like before, I'm going to take him and plug him in there, just because I can. And x equals negative 2 times by negative 8 minus 6. So I plugged in negative 8 for the y variable. And now x equals 16 minus 6, x equals 10. And there we have it. Hopefully you got the same answer as me. Even if you use the elimination method, if you use a different method than me, you should still get the same solution. Now, what happens when the systems of equations get more challenging? Here, check this out. I've got fractions and fractions and fractions and fractions, and this would be a huge pain in the butt to solve algebraically just the way it is. Now, graphing calculator peoples, I'm going to solve this using the graphing calculator first, and then I'm going to solve it by hand. So it's y equals, because both these equations are already y equals, so that kind of saves me a little bit of work. Y equals fraction of 5 5/8 x minus, and by the way, you could just as easily say this, 17 divided by 8. You don't actually have to do the fraction thing. The calculator understands and does order of operations. Now, if you like the fractions, by all means use it, but there are times where you don't have to do the fraction and the calculator will graph it correctly. But I personally kind of like the fraction. I just actually learned about this feature just this past year, I think. 2/7 x plus 17/7. Oops. 17/7. All right, double checking my equations. Negative 5/8 x minus 17/8 and 2/7 x plus 17/7. All right, so if I hit graph. There's the one with a positive slope. There's the other with a negative slope, positive slope. They intersect right about there. Now, in order to find out what that is, I'm going to use the calculate feature. I'm going to calculate the intersection. And it says first curve. Yes, I'm on the first line. Second curve. Yes, it's on the second line. Guess, where do I think they intersect? I'm going to move the cursor close to the enter point, or the intersection point. It doesn't have to be right on, just close. All right, and my guess is right around here, and it's calculating. So negative 5 and 1. Negative 5, comma 1. That is the solution we should hopefully get when we do this by hand. Okay, now how would you do this by hand? Honestly, it's probably not quite as bad as you imagine. So here, my two fractions, or my two equations, I would like to be able to get rid of the fractions. If I could make this thing have no fractions in it, that would be fantastic. And I can. And this harder part of the equations that we're doing now, there's really no allegiance to substitution or elimination. You just solve using the best method. So I'm going to multiply this whole equation by the common denominator of all fractions. In this problem is 8. What that does for me is I'm going to get an 8y, a negative 5x, and a negative 17. You're going, what? Well, 8 times y is 8y. 8 times by negative 5/8. 8 times by I hate this little menu. Negative 5 over 8 gives me negative 5. It essentially, like this 8 and the 8 in the denominator kind of cancel each other out when you multiply. And the same thing is going to happen here. If you type this in your calculator, you're going to get negative 17. Look, no fractions. Now, my second equation. I'm going to multiply the whole equation by the common denominator of 7. I'm going to get 7y equals 2x plus 17. Now check out these two equations. I can now solve that using substitution or elimination or whatever method you want. And honestly, I've had some students who they don't multiply both equations by something. They'll just maybe substitute and then use the calculator to do a lot of the ugly work for them. Fine, whatever. I personally would I like the elimination method. I'm looking at these two equations like, man, I wish I could just eliminate them. So I'm going to. So 7y equals 2x plus 17. I lined them up. I just copied this equation here. I lined them up. Y's equals x's. Everything's lined up nice and pretty. In order to get these guys to eliminate, I need to have the same number with different signs in front of one of the variables. I'm going to make my x's eliminate. I've just decided. In order to make my x's eliminate, I'm going to make this a 10x. I can multiply by 5 and make this a 10. I can multiply by 2 and make that a 10. And they're going to have different signs. So if I multiply my bottom equation by 5 and my top equation by 2, my x's will eliminate. So here's what it's going to look like. It's going to be 16y equals negative 10x minus 34 over 35y equals 10x plus 170. I lied, not 170. I multiplied by 10 instead of multiplying by 5. What is 17 times 5? 85. Let me double check my math, make sure I didn't make any mistakes. 16y equals negative 10x minus 34. I'm pretty sure that math is good. Yeah, and then 35y equals 10x plus 85. All right, so my x's will now eliminate. And my y's give me, if I add my equations together now, 16 plus 35 is 51. Y equals a negative 34 plus 85. I'm hoping it's 51. Divide by 51, divide by 51. Y equals 1. Hey, that's the same thing we got before. I mean, remember, because we're doing this the other method now. So I got the same solution the calculator gave me using my elimination method. I got rid of my fractions, and then I eliminated. And then I'm not going to show you, I mean, to get the negative 5, I would now plug this one not into the originals. Any of the equations that have x's and y's, I would plug in 1 probably right here or here. And if I solve this bottom equation, I said I wasn't going to show it, but I guess I will. Be a good teacher. If I plug in 1 for my y variable and solve this equation, I should get x equals negative 5. There's 7 equals 2x plus 17. I'm going to minus 17 on both sides. That gives me negative 10 equals 2x. When you divide by 2 on both sides, x equals negative 5. And that's the the x value we got up here. Okay, so solving by calculator, solving by hand. Getting rid of fractions by multiplying the entire equation by something to making the fractions cancel. Okay, what about that? Well, I'm going to do the same sort of thing. Like, I'm looking at this. My bottom equation, my common denominator is 5. That's the only denominator. So if I multiply the entire equation by 5, I'm going to get x, because this is essentially a 1x over 5. So I'm going to x plus y equals -2. You could think of this as a 1/5 x. It would be like 1/5 x, sort of like that. And a 1/5 y. This is equivalent. So by multiplying by 5, 5 times by 1/5 is 1 y. And then did I finish? Oopsie, I forgot. Or that's actually a very common mistake. Is a lot of students, they mess up on this number on the other side, like I actually just did on accident, because 5 times by -2 should be -10, but some people just it goes out of their mind and they just rewrite this number. I did it on accident a second ago, and it happens to a lot of students as well. Now, my top equation. I want to multiply by the common denominator. Well, common denominator of 3 and 2, that is the least common multiple. What is the least common multiple of 3 and 2? Now, I showed you how to do it on the other calculator. In this calculator, it should be there as well. I'm not exactly sure where it is. It's somewhere. Where would least common multiple be? Is it number? Min, max, integral, absolute value. So, oh, there it is. Number 8. So under number, least common multiple of 2, 3 is 6. I could have done that in my head, but I was showing you how you can use the calculator as well. So the least common multiple of 2 and 3 is 6 because that's the number that's in the times tables of both. If I multiply this entire equation by 6, check what happens. So 1 over 2 times by 6. 1 fraction. 1 over 2 times by 6 is 3. I'm going to get a 3x. 1 over 2 times by the 6 is 3. 1 over 3 times by 6, 1/3 times by 6 is going to be 2. 2y equals -24. I have now got rid of all my fractions. I have these two equations with no more fractions in them. And now I can choose whatever method I want. I can choose substitution, I can choose elimination, I can do anything and solve this system of equations now. So if you like substitution, you can solve this bottom equation for y and plug it in here and then be done with it. If you like elimination, you can multiply this bottom equation by a -3 to make your x's cancel or a 2 to make the y's cancel and then go for it. I like elimination. I'm doing elimination. So I'm going to multiply this. I'm going to multiply the bottom equation times by, let's go with -3. Let's make our x's cancel. So it's going to involve rewriting equations again. So my bottom equation times by -3 is going to become a -3x minus 3y equals a positive 30. My top equation stays the same. 3x plus 2y equals -24. And now when I add my equations up, my x's do eliminate. That was the whole point of multiplying by -3. So I had a -3 and a positive 3. They eliminate. My y's give me -1y. That's 2 plus -3. And my constants is a -6. Nope, I lied. Positive 6. Solve the equation by dividing by -1 and y equals -6. That is the y value of my solution. To find the x value, I can take this -6 and plug it into any of my equations that has x and y. So I could plug -6 in here for y, here for y, here, 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 any of them. Now, out of all of these equations, the one that probably looks the simplest is actually this one here, because the equation is just, it has less stuff less stuff I'm going to have to get rid of when I solve the equation. So x plus -6 equals -10. To solve that equation, I'm going to add 6 to cancel out a -6. And y equals -4. And there's my solution. Okay. I got rid of my fractions by multiplying by the common denominator of all the fractions. I then can make any decisions I want on. I can choose to solve using substitution or elimination or solving for y and plug them in my calculator and using the calculate, the intersection feature. It's up to you. Now, I will say, with all these options, you should be familiar with each and know how to do each. Even though there's methods you don't like to use. I don't really like to do substitution, but I know how to do it. I don't really care for too much just plugging the numbers into the calculator, but I know how to do it. Okay? I prefer this elimination method. That's the method you'll see me do probably 95% of the time if you gave me a choice. Now, there are times that I know substitution will be quicker, and so I'll do that. Okay? So, here's a problem for you to try. I'd like you to pause the video, solve this system of equations, try to eliminate your fractions first, and maybe eliminate your fractions first, and then hit play, watch me eliminate the fractions, see if we did it the same way, and then go through and then pause the video some more and keep going. All right, so go ahead and eliminate your fractions first, and then hit play, or do the whole problem. All right, so I'm going to eliminate the fractions first, so you can check to see if you're on the right track. My second equation, I don't need to do that at all. It's just x and y. There's no fractions. Here, I do have fractions, and the common denominator of 4 and 6, you might have thought was 24. It is a common denominator. It is not the least common denominator. The least common denominator is 12. I can make this a 12 by multiplying by 3. I can make this a 12 by multiplying by 2. That is the least common denominator of these two. So if I rewrote this, 1/4 times by 12 is 3x. 1/6 times by 12 is 2y. So now I've got rid of my fractions. I have 3x plus 2y equals 1. These equations are equivalent. And there's my other equation. If you did not finish solving this system of equations yet, go ahead and pause the video and do that now. If you did, let's keep going. So to make these equations eliminate, I'm going to just copy this guy down here. X minus y equals 3. I'm looking at my equations. This is set up for elimination. X's are lined up, Y's are lined up, equals, everything's lined up. And I can easily multiply my bottom equation times by 2 to make my y's eliminate. I have a positive 2. If I multiply by 2, this will become a negative 2. So that's going to give me 2x minus 2y equals 6. Up top stays the same. 3x plus 2y equals 1. And now when I add the equations together, I get a 5x equals 7. Divide by 5 on both sides, and x equals 7/5. I betcha, if you try to solve using your calculator, you're not going to get 7/5 very easily. Now, if you don't like that 7/5 as a fraction, you can divide it. That should be 1.4. 7 divided by 5 should be 1.4. So you can use the decimal as well. Although typically, if your problem starts with fractions, it ends with fractions. If it starts with decimals, it ends with decimals. So I'm going to keep the fraction. And now, so 7/5 is my x value. To find my y value, I am going to plug in 7/5 into one of my x's and y's. I'm going to use, it's this one here, but it's also down here. So I've got space to work it here. So 7/5 minus y equals 3. I'm going to subtract 7/5 on both sides, and negative y equals 3 minus 7/5 is 8/5. Divide by -1, and y equals -8/5. And there's my solution by hand. Once I've eliminated my fractions from here, I could have taken this and solved for y and then plugged them both into the calculator. Let's see what that looks like. So if I take, I'm going to take this and solve for y. That is just y equals x minus 3. So I'm doing some mental math in my head. If you don't believe me, do the steps. You should get the exact same thing. If I took this one and solved for y, I would get y equals -3/2x plus 1/2. Now, if I graphed those two equations, y equals x minus 3 and fraction -3/2x plus, instead of writing the fraction 1/2, I'm just going to put in 0.5 just to save me some key presses because this calculator is a little slow. All right, make sure my equations are written correctly. Okay, I graph first. 1, 2, and then I do second, calculate the intersection. I move my cursor close to the center, and now first curve, yep. Second curve, yep. Guess around this area. It's already kind of close to the intersection, and it gives me that. Now, this as a decimals is equivalent to this as fractions, but again, I can almost guarantee if this was a question on a test, a PSA or something, they're not going to give you this as these decimals. Because if a problem starts with fractions, it ends with fractions. If it starts with decimals, it ends with decimals. Speaking of decimals, how would we eliminate the decimals in a problem like this? Well, we would kind of do the same thing. I'm going to multiply this entire equation by something. Now, if I multiply by, it's going to be a power of 10, 10, 100, 1,000, 10,000, something like that. Well, I would like it if each of my decimals moved over 2 places. If each of these decimals moved over 2 places, boom, boom, this would be a 5x and a 4y and a -14. That's multiplying by 100. That will move my decimal over 2 places. My bottom equation. I would love it if each of these decimals would move over 1 place. Well, in order to do that, we're going to multiply by 10. Multiplying by 10 moves your decimal over 1 place, and that becomes a 3x plus 6y equals 6. There. I'm just moving my 2 equations together now, so I can solve the system. I would solve using elimination. I'm looking at these 2 equations, and there's, it's going to be the same amount of work to eliminate x's or y's. So I'm going to multiply the bottom equation times by 3 and my top equation times by -5 to make my x's eliminate. That makes this a 15y. So now I have -15x minus 30y equals -30 on the top. And I have a 15x plus 12y equals 3 times 14, 30, 52. Is that 52? No, 30, 42. See, that's why we have a calculator. 3 times 14 is 42. And it'll be a -42. And I eliminate. My x's will eliminate right now. My y's give me 18y, -18y equals -72. I divide by negative 18 on both sides, and y equals negative 72 divided by negative 18 is 4. So I have the y coordinate of my solution is 4. To find the x coordinate, I'm going to do just like I've done a million times. I'm going to plug 4 in for one of these equations that has x and y into it. I'm going to use the bottom one here just because, well, I've got space for it. So right there, I'm going to plug in y is 4 and solve this equation. So we got 5x plus 16 equals negative 14 minus 16 on both sides. 5x equals negative 30, and divide by 5, and x equals negative 6. And there's my solution. So that's how you would solve a system of equations to get rid of your decimals. You multiply the whole equation by a power of 10. You have to move the decimals the same number of places in each of the numbers. So you move it as many times as you need to make them have no decimals. And then once you have an system of equations with no decimals, you just go through and you solve like normal. All right. Looking here. This is a little bit of a weirder question. I mean, my bottom one, this equation here, I'm only going to multiply by 10. I move the decimal over one place, and if this is a 1, one place over makes him a 10. I'm not going to move the decimal over 1, 2, 3 places to make this a whole number. I don't care if he's a whole number. I want the numbers in front of the variables to be whole numbers. So if I multiply by 10, this becomes a negative 12x, a 10y, and a 10.44. This is where I want to have no decimals and no fractions. I really don't care about this other piece. My top equation, I'm going to do the same thing. I'm going to multiply the whole thing times by 10. Becomes a 24x, a 12y, and a 113.52. Now I'm going to use some technology magic and move my equations together. Oopsie. Get back here. And I guess I'll put this guy on top just so we keep track of which equation came from the top and which came from the bottom. All right, in order to make these eliminate now, I see my x's already are almost common multiples. If I multiply this bottom guy by 2, the x's will cancel. So that's what I'm going to do. U times by 2 becomes negative 24x plus 20y equals... Now, one thing you could do, I know I'm in the middle of this, but check this out. If once you do this, you realize, wait a second, if I multiply this by 2, this would be a 24, you can actually do it here. Instead of multiplying by 10, I could have multiplied by 20. 10 times 2 is 20. Check this out. It's going to save me a step. If I multiply this bottom equation by 20, negative 1.2 times 20 is negative 24. I knew that was going to happen. If I multiply 1 by 20, I'm going to get 20y. If I multiply 1.044 times 20, I'm going to get something. 20.88. So you can actually multiply by a couple things in one step, as long as it's from the same equation. Save yourself some paper. I didn't have to rewrite all my equations a second time. Now when I add, my x's do eliminate. My y's give me 32y. My constants give me, I don't know, 113.52 plus 20.88 is 134.4. And then we divide by 32 on both sides. And we get a y value of 4.2. If you start with decimals, you end with decimals. My y value is 4.2, not 4, 2. And now to find the x value, I'm going to take 4.2 and plug it back into one of my equations somewhere. I guess we're going to use, I don't know, doesn't really make much of a difference. This one? Sure, why not? Negative 24x plus 20 times by 4.2 equals 20.88. I'm squeezing it in there. So that gives me negative 24x plus 20 times by 4.2 is 84 equals, I'll make them a little prettier. There you go. Equals 20.88. I subtract 84 on both sides. 24x equals 20.88 not divide minus 84 is negative 63.12. And then when we divide by negative 24 on both sides, divide by negative 24, x equals 2.63. 2.63. And there we have it. Not a pretty answer, but it is an answer. I eliminated my decimals. I then used my elimination method to solve the system of equations, and there we have it. If you could please do this, I believe, last question for the lesson. Pause the video, do it on your own. When you're ready to continue, hit play, and we'll go through it together. All right, now, the order you do these next few steps is kind of a little independent. You could multiply everything by 10 first, is what you would do to eliminate decimals. If you multiply this whole thing times by 10, you could do that. You could honestly almost get away with not multiplying by 10 if you just substituted right now and plugged this in here using the substitution method and solved the system of equations. It would work out just as well. I mean, check this out. With decimals, I'm going to plug this in. So this is getting plugged in there. It becomes a negative 1.5x equals 1.2x minus 4.05. You could substitute first. If the decimals here really bother you, you can multiply everything by 10. This would become a negative 15, a positive 12, and a 40.5. Or, using the calculator, you just keep solving. Subtract 1.2x on both sides. You get negative 2.7x equals negative 4.05. Divide by negative 2.7, divide by negative 2.7, and x equals, I don't know, negative 40.5 divided by negative 2.7. So you're allowed to kind of keep your decimals. You don't have to get rid of them, but a lot of times it's easier. My x value is 15. Let's find the y value. And I'm definitely going to plug the 15 in right here because that's a short, simple equation. So if I plug in y equals negative 1.5x times by 15, I'm going to get y equals negative 22.5. I'm pretty sure, but let's double check. I know 15 times 15 is 225. There it is, negative 22.5. Okay, so now you've learned how to do the elimination method, substitution method, as well as how to get rid of fractions and decimals in harder systems of equations. So why would you want to get rid of fractions and decimals in a system of equations? Well, because it makes the solving harder. If you can get rid of those fractions and get rid of those decimals, it just makes the solving using substitution or elimination easier. And we've learned how to do that. Multiplying by powers of 10, like here, can eliminate decimals, and here can eliminate decimals. If you've got fractions, multiplying by the common denominator, the least common denominator of the fractions, will get rid of the fractions, and then from there you just solve like normal, like we did in the previous lessons. Okay. Thank you so much for watching this lesson on solving systems equations using substitution and harder systems. Until next time, toodles.